Okay, so what we were basically studying, we were studying the प्रिंसिपल ऑफ वर्क एंड एनर्जी। उस पे जो रेलेवेंट एग्जांपल्स रेलेवेंट प्रॉब्लम्स वगैरह है, ठीक है, वो थोड़े से डिस्कस हमने कर लिए, एग्जांपल्स कर लिए हैं एंड प्रॉब्लम्स आप खुद कर लेंगे। नाउ बेस्ड ऑन द सेम concept, let's try to find out the power and efficiency. So why we are doing this topic, what is the basic concept? Okay, please give me a few seconds, I have a call. Okay, so the objective of this topic is basically to find out or to determine the power generated by machines, engine or motor, and also to find out the mechanical efficiency of machines by using the principle of work and energy. Okay, so here I have discussed one of the application. For example, here in this picture we are having this elevator. Okay, so this is an elevator. If we know the force required to lift this elevator, the force which is required with the help of which if this elevator can move to the required destination or to the required place, if we know this force, and definitely how we can know this force, by considering the weight and all those component weight and the required dynamics and mechanics. So based on all these things, if we know the final resultant load or the final resultant weight or the final resultant force, which if we apply on this object or on this elevator, which causes the elevator to move up. So अगर ये force हमें किसी तरीके से find out हो जाए, based on this force, what we can do, we can select our motor, we can select the required motor. So the motor that we will select, it should have the capability to provide the required force to the elevator. And the same I have written over here, that the power requirement for this elevator depends upon the vertical force F that acts on the elevator and causes it to move upward. So if you don't know this analysis, if you are unable to do this analysis, you will not be in a position to design or to select a motor for the required purpose. So this is just one of the application. You can have a number of application, other application. Okay, so we know that power is, can be defined as the rate of doing work. So means if you are having work, if you divide it by time, you can get the required work. So power, it is basically u by t or du by dt, the rate of doing work. We know that du is equal to f dot dr and dt should remain as it is. So we can also write this one as f dot dr by dt. So from dr by dt, this can basically gives us the velocity, right? So f dot v, this is basically equal to work. So work is the dot product of force and velocity. So we can also find it out by using this equation. The unit of work, it is Newton meter per second, and the unit of power, since it's work divided by time, so it should be Newton meter per second, or in another word, it can be joule per second, right? And for power in SI system, we can also write this unit watt, okay, or we can use foot pound per second or horsepower. Okay, so 1 horsepower is usually equal to 550 foot pound per second, and that is equal to 746 watt. So these are few of the conversion जो कि आगे हो सकते हैं आपके प्रॉब्लम्स वगैरह में शायद यूज हो. Then mechanical efficiency. So whenever this efficiency word come, it is usually it can be defined as the output divided by input. So efficiency, it is basically the power output by power input, or it can be energy output by energy input. And remember that mechanical efficiency, it will always be less than 1. Okay, so now let's have an example on this topic, or let's use the principle of work and energy to find out the required power or the efficiency, or to utilize this term power as well as efficiency in our dynamic problem with the help of principle of work and energy. So the motor M of the hoist shown in figure 14-15, this is example 14-8 of your RC Hibbeler book. Okay, so the motor M of the hoist shown in figure 14-15 operates with an efficiency E 0.85. This is the motor. Okay, if you understand this diagram, this is a motor. We are having this rope, right? And here we are having a weight. So when this motor rotates, due to the force that it apply on this rope, the weight, it moves upward. So with the help of this motor is helping this system to lift this weight, right? The weight at point C. Okay, the efficiency of this motor is 85% or 0.85. Determine the power that must be supplied to the motor to lift the 75 lb crate. What we do, we need to find out the power. Okay, so this is the motor. How much power do we need to supply to it from outside, right? So the power that we will supply, for example, if we supply 100 Newton power, 100 watt power to this motor, its efficiency is 0.85. So its output will be 85 watt. Remember this thing, right? So what they are asking, we need to find out that how much power that must be supplied to this motor from outside to lift the 75 lb crate C. The weight of this crate is also given 75 lb. So how much power should be supplied from outside to this motor so that this weight can be lifted? Okay, and at this point, at instant T on the cable, as shown, the acceleration is 4 feet per second square and the velocity is 2 feet per second square. What we need to do, neglect mass of pulley and cable, right? So we need to neglect those things. So if you remember few of the previous topic that includes like the um, absolute motion dependency of one particle on another. So हमारे उसमें हमारे पास जो ropes वगैरह होते थे, so how we used to solve it, how we used to solve such problems?
Datum.
Okay, datum, yes, exactly. In that case we used to define some datum. हम क्या करते थे, एक datum अपने लिए define करते थे, right? इसी तरह होता था ना?
Yes, sir.
So but in that case we used to have like the datum should be till this point only. Yes, this is our datum. So in that datum, for this one we can change our datum, we can have a second datum over here, but let's focus on this one. Just to remind you people, in that case that we used to find out the total length of the rope. So the total length of rope, it should be equal to this SC, and this should also be equal to SC. This length is constant, this length is constant, this length is constant, this length is constant, and they are saying okay that this length, it is equal to SP. So SC plus SC, this will become 2SC plus this length. This length is basically equal to SP, and this should be equal to all those constant. Constant is equal to L. So 2SC plus SP, if this the total length remain constant, this is also constant. When they get combined, this will become again L. So now if we take its derivative, it will become 2VC plus Vp is equal to 0, or 2AC plus AP, it will become equal to 0, right? And if you look at here, we are having AP. Point P acceleration is 4 feet per second square. So AC is equal to minus AP by 2, right? Is it clear till this point?
Yes, sir.
सर ये कुछ पार्ट शो नहीं हो रहा, थोड़ा जूम आउट अगर करना।
सर का शायद कोई इशू आ गया है।
कॉल आ गई होगी, कॉल।
हाँ शायद।
ओके, आवाज आ रही है ना?
यस सर, अभी आ रही है।
ठीक है। So if you want to find out the given data, so given data is given over here. The efficiency is 0.85, and how much power is required for the motor, this should be P in. And the weight of the crate is 75 lb. Point P acceleration, point P velocity is given. Okay, so as I have discussed, we just solve this step. So how to find out AC? This is by this equation. So we get this minus 2 foot per second square. Okay, in this case, if we apply the rule of uh, what we can say, that the summation of forces in case of dynamics. So, and especially if we are dealing with kinetics, so summation of forces in x direction should be equal to max, and summation of forces in y direction, that should be equal to may, right? In x direction, there is no motion, means the crate is moving only in the upward direction, in the vertical direction. So summation of forces in y direction should be equal to may. Do we have m हमारे पास है?
तो 75 वेट गिवन है, तो उससे हम निकाल लेंगे।
ठीक है, वेट से हम निकाल सकते हैं, ठीक है। ओके, सो समेशन ऑफ फोर्सेस इन वाई डायरेक्शन। ओके, नाउ व्हाट फॉर दैट पर्पस वी नीड टू फाइंड आउट द फ्री बॉडी डायग्राम। ओके, इफ ये ऑब्जेक्ट मूव कर रहा है, सो लेट्स से दिस इज 1, दिस इज 2, एंड द वेट इज एक्टिंग डाउनवर्ड, दिस वन शुड बी टी, दिस वन शुड बी टी। ये भी आपके पास यहाँ पे भी जो टेंशन है, ये भी टी होगा। ओके, सो 2t, एंड दिस इज द वेट एक्टिंग डाउनवर्ड। ओके, and the object is moving upward. Okay, so summation of forces in y direction, this should be equal to, it depends on you whether you take upward as positive or you take downward as positive. So if we take downward as positive, as they have taken over here, so in that case, the 75 lb minus 2t, that should be equal to may. Basically the acceleration of point C, right, which is in the y direction. And from here we know that acceleration of point C is minus 2 feet per second. So we can put this value over here, minus 2. And how we can find out this m? This is basically equal to W by G. So W is 75, right? And divided by 32.2, so we will get this value. So in this whole equation, there is one unknown, that is T. So this T is now identified. So the tension that we have over here, the tension that we have over here, the tension that we have over here, all of them are identified, right? Is it clear till this point?
Yes, sir.
Okay. So if we consider this point is input or output of the motor? This is the input or output of the motor? Ji,
Output.
output.
Sir, input है sir.
This is the input. Input is from our side, and this is the output of motor which is going to this system, right? So यहाँ पे टेंशन कितनी है जो अभी मैंने फाइंड आउट किया?
39.8 pound.
And if I want to find out the power at this point, so I should multiply this force with what? With velocity, right?
Yes,
So
sir.
do we have velocity of this point?
Yes, sir. Given.
Okay, Vp. So can I find out power at this point, right?
Yes, sir.
So when we do so, हमारे पास क्या आ जाएगा? ये हमारे पास इस इक्वेशन से ये पावर हमारे पास आ जाती है. This is the required power. ठीक है? This power is in foot per second, means foot pound per second. If you want to convert it into horsepower, you need to divide it by 550. Why? Because 1 horsepower is equal to 550 pound, foot pound per second, right? So how much power is required? 0.145 horsepower. So the power that we required here, it is 0.145 horsepower. But I told you, if this is the motor, this is the output power, which is 0.145, and it is efficiency if it is 0.85. So this should be more than, it should be more than 0.145. If the efficiency is 100%, or if it is 1, then this can be 0.145, right? So as we know that efficiency is equal to output by input, right? How much is the efficiency?
0.85.
So, okay, so input will go here, the input will go here, and this E will come here, right? So this is the equation. From here we put this value, so from here we can find out the P input. So P input is how much? 0.17 horsepower. This is basically, this 0.17 horsepower is the power that we need to supply it from the outside, right?
Yes, sir.
Okay, is it clear? Any question in this, means any query in this question, any problem in this question?
No, sir.
Okay, now let's move forward. Okay, so again, if you go to RC Hibbeler, there is one example 14.8. I have done this 14.7, 14.8 problem. The one that I just did, it is 14-8, and the one that I suggested for you, it is 14.7. That one is simpler one. Okay, and you can also do problems 14.53, 14.62, and if you feel there are other relevant problems, you can also go through it just for your practice. Okay.
Yes.
Okay. Now let's move towards another topic, that is conservation of energy. Conservation of energy, basic concept is that the total amount of energy will remain conserved, right? This what this title basically shows, and in which case the energy will remain conserved, or under which scenario the energy conservation laws will be applied, we will study in this lecture. So conservation of energy, what does that mean? The total energy of the system will remain conserved or constant under what condition? If the work is performed by only conservative force or forces. So what is conservative force, or what we mean by conservative forces? So if the force does not depend on the path, right? Means if it is independent of the path, and it depends on the initial and final position of the path, in that case the force will be termed as conservative force. But in this case we are talking about the force that is doing some work, right? So let me redefine. If the work of force mean that force which is performing some work, if it is independent of the path, mean if it does not depend on the path, and it depends on the force initial and final position on the path, then we can classify this force as a conservative force. Or we can also define this one as a force with the property that the work done to the object only depends on the initial and final position, but is independent of the path taken. Is it clear? Example of
मतलब कि
conservative force can जी
ये
जी
फोर्स स्टेट डिपेंडेंट है अब।
प्लीज दोबारा पूछे।
मतलब कि सर ये फोर्स जो है ये स्टेट डिपेंडेंट है।
जी exactly. It depends, means for a given path, if it depends on the end positions only, right? Okay. For example, gravitational force and spring force, both of them are conservative forces. For non-conservative forces, one of the example is basically like frictional force. It depends on the path. Or you can say the applied force, the external applied force. It can also be termed as non-conservative force. Okay. What is energy? We already know this is the capacity, this is the ability of doing work or for doing work, and the energy that is associated with the motion, that is known as kinetic energy. Energy associated or energy comes from the position usually termed as potential energy, right? So how we can define potential energy? For example, if this is the object, if this is the datum, so due to this position, this object will be having some energy, right? So if this object move from this position toward the datum, how much work will it perform? That is basically its potential. That is basically its potential energy. So potential energy is the measure of the amount of work a conservative force will do when it moves from given position towards the datum plane, right? So in mechanics, the potential energy due to gravity, means weight, or elastic spring is important, and more importantly in dynamics or in mechanics, we are more interested, in most of the cases we are more interested in change in potential energy rather than the absolute value of potential energy. What does that mean? You will get it clear in the next slide. Okay. And how we, for example, if this is the point, if you want to find out the potential energy of this point, so usually the equation that we have is mgh or mgz. Remember this equation?
यस सर।
So this is same equation as mg is w and z is basically the height, right?
जी
So this
सर।
point is having its own potential, it is having its own potential, this is having its own potential, right? Okay. If you put some datum, if you put the datum over here, so if we allow this object to reach the datum, how much work will it perform? Zero. If we allow this object to release from its position and so that it can reach till this datum, it will perform how much work? mgz1 or wz1. Okay, if the object is over here and if you want to take it to the datum, so it will not give you any work, rather than you have to provide some work, right? Okay.
यस सर।
For this datum, it will be having some potential energy. If I put the datum over here, the potential energy will be decreased. If I put the datum over here, the potential energy will be again changed. So the absolute potential energy is basically depend on the datum. If you change the datum, the potential will be changed. But for example, if I want to find out the change in potential energy if the object move from this location to this location, or the change potential between these 2 points, it will remain the same whether you put datum over here or datum over here or datum over here. That's why we are interested in change in potential, or in most of the cases we consider the change in potential energy rather than its absolute value, right? So if you move, means if you are above the datum plane, if your position is above the datum plane, so the potential energy will be positive. And if the position is below the datum plane, so potential energy will be negative, right? Okay, as I have discussed that in case of dynamics, the two forces which we basically consider are the potential energy and which we are interested. One is basically the potential energy due to gravity, which is the potential energy due to weight, which we just discussed. And the second one is the elastic potential energy. what is the elastic potential energy? For example, if this is the spring and if this is the particle attached to it, right? So the elastic potential energy, this is basically the potential of the spring to perform some work on this particle, right? It is the potential of the spring to move this particle or to perform some work on the particle attached with it or attached to its end. Okay, as I have already told that for spring, the unstretched length is taken as a datum where we have zero deflection or zero extension. And then if the particle moves towards the left, so what we can do, for example, if this is the datum, if I set this one as positive, this one as negative, so during compression it is moving towards left, so this will be negative, s1 will be negative, and during extension it will move towards the right of the datum, since right of the datum is positive, so s2 should be positive. And we already know that the 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 work done or the equation in case of spring for work done was half k s2 square minus s1 square, right? Similarly, for elastic potential, the equation that we have, that is basically given over here, it is shown ve is equal to half k s square. If you observe this equation, the deflection in this case or the extension or the displacement over here that we have, it is s square. So whether we have compression or extension, whether we have a positive displacement or a negative displacement, in both cases the result will be positive because it is having square value. That's why the elastic potential, it will always give you a non-negative answer, right?
Yes, sir.
Okay, so conservation of energy, what is the concept of conservation of energy? The concept is very simple. The total energy before and after, it should remain constant, right? So the total energy before and after, it will be the combination of kinetic and potential. So kinetic is represented by T1 and potential is represented by V1, and this potential, it can have further two components. One is potential energy due to weight and the other one is elastic potential. So the total energy before and after, it remain conserved, and this is the concept of conservation of energy. If you are having more than one particle, if you are having system of particles, so for system of particle, we will take summation of kinetic energy as state 1, summation of potential energy as state 1, and then summation of kinetic and summation of potential at state 2. Before and after means summation of kinetic energy of all particles, summation of kinetic potential energy of all particles, right? So for system of particles, since we are having more than one particle, so we use this sigma T1 plus sigma V1, that should be equal to sigma T2 and sigma V2. I hope this point is clear.
Yes, sir.
Okay, now let's have an example. A 10 kg collar travels along a smooth slope. Word smooth is here, so means no friction, right? This collar, you see over here, this object move like this, the spring also move downward with it. It moves, so the spring also. So at this location, the spring is compressed. When it moved downward, the spring, you can see the spring get compressed, right? So the weight is 10 kg. A 10 kg collar travel along a smooth slope as shown. If at S1 here, its velocity is 20 meter per second, determine speed when it gets to S2. What they want? S2, right? The spring remain horizontal, means spring will remain horizontal. Okay. It has original length of 8 meter. How much is the original length of spring? G,
8 meter.
8
That's
meter.
one.
How much is the length of spring over here? G, at
16.
S1,
16
16,
डबल होगी
16, 16. So this means at state 1, how much is the deflection?
8.
If this is 8, this total is 16. So how much is the deflection?
8.
So S1 should be 8, right?
Yes.
Yes, sir.
What about the length now? How much is the length now? At
10
S2?
meter.
10 meter. Okay, initial length was how much?
16.
8. Now is,
Yeah.
so S2 should be how much?
2 meter.
2.
2
2
meter.
meter, right?
Yes, sir.
So from this diagram, what we can do, we have x1 value, we have x2 value, right? From this we can have y1, y2. Okay, do we have y1?
सर हम निकाल सकते हैं.
If we put x over here, we can find out y1, right? Can we have y2?
Yes,
Again in
sir.
this equation, if we put x value, right? Okay, we can find out this thing. Okay, हमें s1 का भी पता लग गया, s2 का भी पता लग गया, ठीक है? Do we have k? k भी हमारे पास है, right? Find out क्या करना है?
S2 नहीं.
v2 हमने find out करना. Okay, so if we apply the law of conservation of energy, what does it say? T1 plus v1 should be equal to T2 plus v2, right? What is T1? Half mv1 square. ये तो हमारे पास ये भी है, हो सकता है ना?
Yes, known as.
ठीक है. This v1 is basically potential energy, right? इस potential energy में दो चीजें हैं, क्या क्या है इसमें?
Weight.
Weight और
v और इलास्टिक पोटेंशियल, यही है ना?
Yes, sir.
ओके, वेट के लिए क्या करें? वेट के लिए कौन सी इक्वेशन है?
mgz वाली.
MGZ.
mgz वाली, ठीक है? m g
Yeah.
और what will be z? Delta z should, in this case it should be
Y.
delta y,
Y.
not
Yes,
yes,
sir. Y.
ठीक है? So y2 minus y1, do we have delta y?
Yes, sir.
Okay, and it should be negative, right?
Yes.
Minus mg. Okay, what about ve, elastic potential? Half k s square, right?
Yes, sir.
और
K s square. So what about s2 minus s1?
8 यहाँ पे.
यहाँ पे s2 minus s1 how much हो, कितना होगा?
Sir, S1 तरफ नहीं यूज करेंगे.
सिर्फ
V1.
S1 यहाँ पे क्योंकि V1 और S1
दोनों यूज करेंगे ना, बिटवीन 1 and 2. स्टेट 2 पे हमने वेलोसिटी निकालनी है ना. क्वेश्चन पढ़ लें.
लेकिन सर ये तो एक्चुअल से है ना S1 तक. अगर
Oh,
V1 हम
sorry. Yes. I mistaken. ठीक है. Yes, it should be S1, and this should be Y1, right?
Yes, sir.
Right. Okay. Sorry. This should be Y1. This should be S1. First we will do for T1. First we will find out T1. Then we will find out VW, right? At 1. Then we will find out VE at 1, right? Then we will
Yes.
find out the same thing at T2. Then VW at 2 and VE at 2, right? And what we will do? We will put both of them together. Like this one should be equal to this one. Is it clear?
Yes.
Yes, sir.
Okay. So like see, पहले हम करेंगे T1 निकाल लेंगे, ठीक है? Is it clear?
Yes, sir.
And then we will find out G1 means gravitational potential energy, VG1, which is equal to WY1, and we know how to find out Y1, right? This is the answer. And then the elastic potential at S1. Why this is 16 minus 8? Same as this one, right? S1 was 8. 16 minus 8, which is equal to 8, right?
Yes, sir.
Okay. Now let's move toward the second state. Kinetic energy as state 2 half mv2 square. ये तो हमने find out करना है, m है लेकिन v2 नहीं है. So mv2 square. What about gravitational? wy2. Do we have y2?
Yes, sir. हमारे पास है.
Okay, find out कर सकते हैं. Okay. Then ve2 half k s2 square. Half k s2 square. Do we have s2?
Yes, sir.
10
2.
minus 8, which was 2, if you remember. If you remember, it was 2, right?
Yes.
Okay, so from here we have find it out this thing. Now what we will do, add this one and add this one and put them both together. Both should be equal. T1 Vg1 Ve1 should be equal to T2 Vg2 Ve2. When you put those values, there is one unknown which is V2, and from here you can find out V2, right?
Yes, sir.
Okay, so you should do the example 14 from 14.9 to 14.11. Again, it's from RC Hibner book and all related problems with this topic. So you can go through it if you feel any problem or if you want to discuss anything. So you can contact me. So this is basically end of this lecture. If you have any question regarding this topic, you can ask me. If you don't have question, then first we will put the recording off and then you can ask the remaining question. G. Should I put the recording off?
Yes, sir.
Yes, sir.
Okay.